Humans have been evolving on Earth for hundreds of thousands of years, but have you stopped to consider how different life has been throughout those times? Have you thought about all of the different assumptions scientists made, or the theories that were held to be true, and how so many of them turned out to be false? One of the biggest changes in scientific theories was the change from a geocentric theory to a heliocentric theory. Now you might be asking yourself, what is the geocentric and heliocentric theories? Just sit back, relax, maybe even grab some popcorn while we dive into the change from society believing in the geocentric theory to the newfound heliocentric theory. Let's travel back in time to Alexandria, Egypt around 150 CE, where we'll look at the ancient Greek-Roman astronomer and mathematician by the name of Claudius Ptolemy, the man credited for creating the first model of a geocentric universe. The geocentric model stated that the Earth stood stationary at the center of the cosmos, while other celestial bodies, including the Sun, Moon, planets, and stars, all moved in circular orbits around the Earth. He was aware that the size, motion, and brightness of the planets varied through studying the sky with his naked eye, so he incorporated Hipparchus's notion of epicycles, as well as Plato and Aristotle's discoveries, which were all put together a few centuries earlier, to work out his calculations. Epicycles are small circular orbits around imaginary centers on which the planets were said to move while making a revolution around the Earth. By using Ptolemy's tables and diagrams, astronomers could accurately predict eclipses and the positions of planets. Because real visible events in the sky seemed to confirm the truth of Ptolemy's views, he published his findings in a book called the Almagest, where his ideas were accepted for centuries. Now it's time to flash forward to the 16th century, where a new astronomer and mathematician comes into play, Nicholas Copernicus. Copernicus was a Polish man born in 1473 who worked for the church and in his spare time liked to observe the night sky. His observations of the skies led him to believe that the original Earth-centered model was incorrect. Along with his observations, the calculations he had been working on pointed him towards supporting an idea that it was the Sun that was truly at the center of our universe and not the Earth. He believed that the Earth, along with the other planets, moons, and stars, were the ones actually orbiting the Sun and not the other way around. During this time period, this belief was strongly disputed as the Church held the belief that the Earth was the most perfect celestial body and it had to be the center of the universe. Although Copernicus's beliefs had been shunned by the Church and society, he published his findings in a book called On the Revolutions of the Heavenly Spheres, which was crucial for what's about to happen next in the search for the truth about our universe. In the following century, two men played a crucial role in further exploring the findings of Copernicus written in his book, one being Galileo Galilei, an Italian astronomer born in 1564, and the other being Johannes Kepler, a German astronomer, mathematician, astrologer, and philosopher born in 1571. Galileo, who created his own telescope to dive further into the cosmos and see what he could find, discovered that there were moons orbiting around Jupiter, now called Galilean moons, that provided evidence of celestial bodies orbiting a planet other than Earth. He also observed the phases of Venus, which were inconsistent with the geocentric model but aligned with the predictions of the heliocentric model. To further help support these laws came Kepler, who introduced the idea that the planets move in elliptical rather than circular orbits, and that their movements in these orbits are governed by a set of laws, which became known as Kepler's laws of planetary motion. These three laws stated that the orbit of a planet is an ellipse with the Sun at one of the two foci. A line segment joining a planet and the Sun sweeps out equal areas during equal intervals of time. The square of a planet's orbital period is proportional to the cube of the length of the semi-major axis of its orbit. Kepler's prediction noted that when an object orbits a star, its speed changes depending on the distance away from that star. When it's further away from the star, it's slower, whereas when it's closer to the Sun, its speed is faster. These observations would further be explained by Isaac Newton's observations of universal gravitation. To help put all of these works together, Isaac Newton, who had already written his findings of the three laws of motion in 1687, came up with the law of universal gravitation that was heavily linked to his original three laws. Newton's law of universal gravitation described how every object in the universe attracts every other object with a force proportional to their masses and inversely proportional to the square of the distance between them. This law explained the gravitational forces governing the motion of planets around the Sun. Newton's laws unified celestial and terrestrial mechanics, providing a single, coherent framework for understanding the motion of objects both on Earth and in the heavens. Now, it did take a little while for the Church to finally accept the heliocentric theory, but as time progressed and more astronomers and scholars started to follow the findings of these mathematicians and astronomers, there was no other choice but for them to change their beliefs in 1758. In today's world, modern scientific advancements have led us to further prove these findings, as well as note that what these astronomers were studying wasn't the universe, but merely just our solar system. In summary, we have Copernicus, Kepler, Galileo, and Newton to thank, as they all played vital roles in the development and validation of the heliocentric theory, with Copernicus formulating the initial model, Kepler supporting him with the study of ellipses, Galileo providing observational evidence, and Newton providing the physical laws that explained and supported the heliocentric model. Their contributions collectively revolutionized our understanding of the cosmos. Thanks for watching, and I hope you all learned something new about how the heliocentric theory came to be.